everyone. I'm not sure if this is going to be a series or not, but I just wanted to make a quick video on grid-based movement. Now, there are a few systems out there already for grid-based movement, but they're really expensive, and the cost of making your scene bigger is just not really worth it. So if you wanted to make a grid-based game, it would have to be really small. So I'm going to show how to do a grid-based movement system that is more mathematically based, so you don't have to deal with tags everywhere or invisible markers that you have to copy everywhere. There are a few things that I'm going to be going over. If I make another part, if you guys want one, depends really on how this video performs, but there would be collision detection that you would have to do, which I'm guessing you wouldn't really have to do with the tag system, but I'd say that's a lot cheaper than making like hundreds of tags. So what we're going to go ahead and do is, first off, just get a blank puppet, place them down, and I'm going to go ahead and extend out the size of our platform to work with, because why not? Give us some more space to play around with. And this is fairly simple, so what we're going to end up doing is we're going to go and scope in to the puppet with L1 and X, open up the logic, and what we're going to go ahead and want to do is we're going to go ahead and delete the wires heading into our puppet interface here. And I'm going to go ahead and move stuff out of the way so we have more room. And I'm going to go ahead and explain. I don't want to be able to exit what this system is. Basically, we are going to go ahead and set up an internal coordinate system in our puppet here, and this can work for practically anything. And what we're going to go ahead and do is we're going to make it so you can go ahead and place down this puppet anywhere, and it will snap to the nearest location on the grid, and then any movement you do is grid-based, so with the D-pad. So first off, the actual formula that we're going to go ahead and use, we're going to need a grid size. So what we're going to go ahead and do is get a value slider, and this is going to define how big our grid is on like a coordinate scale. So I believe 1, I'm not sure if that's like, I think that might be just moving it like this. So that's why we have the slider, so we can play with it basically. So I'm going to go ahead and set the maximum value to 5, and this is going to be our grid size. And I'm going to go ahead and set it to 2 by default. I think that's a good number to work with. Alright, next is the actual math. So the math part, what it basically does is we're averaging out and rounding to this grid. So in order to do that, we need a calculator. So we're going to go ahead and get that from the logic and processing section. And what we want to do with this calculator, well, first off, we're going to divide by the grid size. Then we're going to go ahead and make a copy of this calculator. And we want to go ahead and round this value. So just do the round. And I forgot to set this calculator to divide. And then we're going to take the result from the first calculator, plug it into the second calculator, which is round, make another copy. And then this one's going to be multiply. And here we're going to go ahead and multiply by the grid size. So we're basically dividing to get a number that we can round, and then we're multiplying it back out so we get the original number. But this way, it's constrained onto this grid because we're rounding it. Alright, and now that we have this, we want to, first of all, put in the actual coordinates, and then we want a way to actually move to these coordinates. So what we're going to do is we're going to go and put this in a microchip, and we're going to call this grid snap. And I'll go ahead and just change the color a bit, and we'll do pre-snap, and then another node for post-snap. And I think I forgot to mention that we were getting nodes in the first place. So go ahead and get those. We need two, one in and one out. So they're in logic and processing. So post-snap. Alright, so we have pre-snap and post-snap, and we're going to go ahead and just move these gadgets into this microchip, basically. And just plugging this in from the pre-snap is going to go into the calculator, and then the end calculator is going to go into the post-snap. So we have the pre-snap node plugged into the A port on the first calculator, and then on the last calculator, the result is plugged into post-snap. No, I don't want that. I'm going to go ahead and turn off the grid for now. But now we have something to apply grid movement to. And what we can actually do with this is we're going to go ahead and get a tag. We just need one from our sensors and input. And what we want with this is basically just the Y position, so we can know where we're snapping up and down. And we also need it to basically be able to understand where we are initially. So I'm going to go ahead and I selected it, and I moved the gizmo directly to where the player is standing. In this case it's a player, but now we're going to go ahead and get a splitter from logic and processing. And what we're doing is we're going to split the scene space transform. This way we can get the actual coordinate that our player is standing on. And now, basically, we want to be able to take this and apply it to an actual internal coordinate system, and that's not actually hard. All we need to do is get a calculator, and we're going to go ahead and plug this calculator into itself. So the result is going to plug into operand 2, or B. And what this does is it creates a local variable. Now a local variable is basically just storing a number. So basically what this is doing is it's adding B to itself constantly. It doesn't add it recursively, it just keeps the value stored, and it adds whatever's in A. So basically we can add negative or positive numbers to it, and it'll give us a coordinate, or not a coordinate, but a number that we can use. So we can go ahead and have one for X, and depending on how you're looking at it, this would either be Z, which is forward and backwards, or Y, which is up and down. So depending on where your camera is, you might want to name it differently, but since the sticks do X and Y, I think we'll do Y for now. So X and Y. Alright, and now that we have local variables, what we're going to want to have is basically a way to modify that. And we also want to use this as our position to where the player is going to go. So we're going to go ahead and get a combiner. And we're going to make it 3 numbers, the same as this splitter. So we have X, it's going to go ahead and go to A, and then Y is going to go to C, because C is actually Z, like I said. And since we're moving the player this way and this way, we want Z. And then Y is up and down, so we want the Y from our tag, just to have that stable. And that's going to go ahead and plug into our grid snap microchip here. And now, what we're going to want to have to do is actually convert this into a way that a player can move. So, the first thing I want to do is actually get the system for moving. I do have a microchip specifically made for this, but I'm going to go ahead and recreate it here because I know this tutorial isn't very long, so I mean, it might as well. It's not going to take that long. So all we need to do is we're just going to get a node, and this is going to go ahead and be our position that we want to move to. And then we're going to get a node and place it on the other side of the microchip, and this is going to be our movement output, basically. That's going to be just sticks, or not sticks, but the gamepad icon. This is going to be position-based movement. Of course, now I'm just going to go ahead and plug in the grid snap output into our position here. Now what we want to do is get this position and somehow turn it into a way to move. Well, that's actually really easy. All we want is a lookout rotator. And what this will do, I'm going to go ahead and turn down the max distance all the way. And I'm going to go ahead and turn the little gizmo here to face the front. I'm not sure if that's required, but hey, might as well. What this is going to do is not actually turn the player. So we want to turn down the rotation strength and dampening and speed all the way down. What this is going to do is we're going to go ahead and feed it a target position, and then we're going to take the scene space direction and output that as a position to move in. And this is basically what we're doing is this is going to take that position and then it's going to try to look at that, and it's going to tell us the direction that the target is in, therefore giving us the direction to move. So we're going to go ahead and plug in that position here. And there was a little bug in the testing, so there is going to be something that we have to do additional other than that. And that would be, we're going to go ahead and get a splitter. And we're going to go and output the scene space direction. Because this input for walking only takes like sticks, which is up and down and left and right. And this is up and down, left and right, and forward and backwards, basically. X, Y, and Z, and we only want X and Y. So we're going to go ahead and get a combiner. And we're going to do sticks. So X and Y. We're going to go ahead and plug that into our movement node output. And then A is going to be X, so that goes into X. And then C is forward and backwards, so we want that to go into Y, because that's how our puppet moves, is forward and backwards and left and right, but it has X and Y instead of X and Z. It's kind of confusing, but not really. So the little bug here is that once it reaches the position, it will try to basically continuously move to it, and you get weird rotations like this. The way to fix that is what we're going to go ahead and do is, of course, get another calculator. And we're going to do absolute value. And what this does is turns negative numbers into positive numbers. That way, we're basically detecting if A or C in this output. So we're going to plug A and C into the calculator here. We're going to make a copy of the calculator. Why do we still have the grid on? I thought I turned that off. And now we basically get to see if there's any activity on this line. Now, calculators aren't very sensitive for decimals. If we were to play, for example, this and let it go, you can see that it very briefly flickers between negative and positive, but there's no actual numbers here. And that's because calculators don't process, or specifically for some functions, not all of them, like greater than, less than, and equal, they don't deal with decimals very well. But all the other operations do for some reason, like multiply and divide. So what we need is basically, we don't really need anything else, because we can do greater than, and as long as this isn't some minuscule number, this is going to output result true, which is going to be 1, which we're going to use to turn on this combiner. And when it's turned off, it can't move, so it's going to move and then turn off. And bravo, it's not going to do anything. Okay, last part would be player input. Now there's a couple ways we can do this. So I'm going to go ahead and try out an easier way that's not entirely sure if it's going to work, but in my testing, I used these D-pad buttons because it seems simpler, but on the second page of the controller sensor input, there's directional buttons, and these are actually camera relative. On the third page, these are just raw, and they're not camera relative. So if we do camera relative, hopefully we don't have to do that much of a difference for the camera. But I have a feeling it's not going to work out in our favor. But all we have to do is we're going to split the directional button output. That's going to give us like an A and B, which is X and Y. So up and down, left and right. So X is to X, and then Y is to Y. And let's see if that works. It might be a little bit backwards. Nope, it seems to be working fine. And here we have grid-based movement. There's even diagonals in this case. One thing that I do want to make sure that we aren't glitching out on is that we actually want these signals to be pulses. We don't want it to be constant. So what we're going to have to do is we're going to go ahead and get a signal manipulator. And we're going to open up the properties of this, and we want to do pulse on input on. Not entirely sure if this works for negative numbers, but we will see. And we want 2 of these. And we're going to plug A into one, and then B into the second one. And this way, we only get a pulse, so we only move 1 unit at a time, basically. Now, if you want to have constant movement, that's fine. Okay, I don't think the signal manipulators are working properly. Let's see. Yeah, it's not pulsing like I thought it would. It's probably because they aren't constant values. What we could do is we could get a calculator, and I'm gonna go ahead and turn off the pin to screen here. And what we're gonna do is we're gonna go ahead and round up. This way, any value instantly becomes 1 that is below 0, or any value becomes -1 if it's below 0. So this way we should have a full value. So now if we go ahead and play test, does almost consistently work. Again, because it's camera relative, you get like some mixing of signals. I'm not sure why. It doesn't work 100% of the time because of the mixing of signal. Also, I don't think negative is working. Or, yeah, negative isn't working because signal manipulators don't like negative numbers. So there is a way to fix that, but I feel like we're at like 20 minutes. It's not going to take that long. I mean, the concept is already here. Might as well go ahead and apply it. What we need to do is get a splitter. And we're going to go ahead and split both of these values, A and B. And we're going to go ahead and pulse all of these signals and then recombine them in a combiner. This way, we don't have to worry about negative numbers because it's always positive when you split a regular signal like so. So, yeah, this is the right combiner. And we're just combining back the signals again, plug them in. There we go. Now that should work. Yep. Works almost 100% of the time. I'm not sure why. There's like a brief period that you can't walk after you've already walked. I'm not sure why. That was completely wrong. Okay. That's completely wrong. Why is that happening now? See, the camera relative stuff doesn't work 100% of the time. Pressing up on the D-pad. Why are you doing this to me? That's why it's better to make that system yourself or to not have the third-person camera in the first place. Which would be a lot easier, in fact. If we just go ahead and use this page controls instead, the third page, the D-pad, since we already have all these signal manipulators, we might as well. So X is left and right, so left would be negative, right is positive, and then up is positive, and down is negative on the D-pad, like so. And now all we need to do is get a camera. Luckily, I have a pre-made camera that's just a follower and a camera on a cube that I'm going to use because I'm lazy and I want to end this tutorial because I wanted it to be short and we're already hitting 25 minutes. So, how does the grid keep turning back on? I swear I'm not turning it on. Okay. There we go. Oh, it's upside down. Oh yeah, you want to know why? I would no. That's not it. That's not it. That's not why it's upside down. I'm just gonna switch the up and down signals. There we go. And now we have a successful grid-based movement. Of course, we could also have a static camera. Instead of this guy, we can just put it on a camera. Like so. So you could have like a battlefield of sorts. Or you could have like grid on the floor. And it's upside down again. Which is fine. That's fine. There we go. And now we have successful grid-based movement that works very well. And of course you can play with the grid size to your liking. If this is too far out for your grid, then you can go ahead and shrink it very easily with this doohickey here. We'll do 1 for now. That works. That will make it even smaller. That's a much smaller grid. And of course, you could always make the signal constant if you want something like Pokemon. I'm not sure how that would work. I'm not sure if that would work very well, but I'm curious. I'm curious. This video is pretty much over. So yeah, if you guys would like me to continue this series on how to do like AI, obstacle detection, and maybe even a turn-based battle system to go along with it, go ahead and leave a comment about that. Oh yeah, this is way ridiculous to do it this way. You would have to like slow down the signal or something. Yeah, if you want to see more of this, go ahead and comment. If you want to see a different tutorial, go ahead and comment. If you want to see anything specific, just let me know. Also, I've got a Patreon. If you want to support me there, it helps a lot. Helps me put videos out faster. Because work is a kind of an issue for me right now. So, yeah, if you guys like the video, go ahead and like it. Go ahead and comment, subscribe, you know, all that stuff. Bye. Bye, everyone. Bye.